Welcome to our Math 30-1 preview. Each course in pretty much any region is divided into general and specific outcomes. The curricular outcomes for Math 30-1 are divided into three categories or units. There's trigonometry, there's relations and functions, and there's permutations, combinations, and binomial theorem. Today we are going to be giving you a preview of what we're going to be seeing in the trigonometry unit in Math 30-1. There are 6 specific outcomes within this unit. All 6 go with the general outcome, develop trigonometric reasoning. The first of the specific outcomes is it is expected that students will demonstrate an understanding of angles in standard position expressed in degrees and radians. Okay, that's all well and good, but what does that mean? Well, as you no doubt recall, we have a specific set of axes we usually work with, the Cartesian plane or the coordinate axes, in which we have the positive x-axis going to the right and the positive y-axis going up. Now, when it comes to practical real-world applications, generally speaking, we use north or up on the map as the standard direction. That's not the most natural one in math. The most natural angle in math is to actually start from the x-axis and measure counterclockwise. So if we have a specific angle coming out in any direction, then that angle will be measured relative to that x-axis in the counterclockwise direction. If you measure it clockwise, then you're giving that angle a negative number. And we talk about measuring this in degrees and radians. Degrees are the ones we are familiar with, or most familiar with at this point. So that is, as we learned in Math 30-2, where we take the entire circle and divide it into 300 degrees, as opposed to the radians. Radians being the more natural mathematical measure. And for this, it's best to draw another diagram. So here we have an angle, and this would be a segment of a circle. It'll subtend an arc. So if we have this wedge with an angle theta in the middle, a radius r, and an arc length, so the length of a piece of string that perfectly fits this curve, of S. Sorry, that was not well drawn. Let me back that up. We want our arc length to fit that curve. That's our S. Then S equals r theta. If our arc length is the entire circumference of the circle, then our arc length is 2 pi r, which is going to equal r theta. The r's cancel, and our theta equals 2 pi. So in radians, that entire circle is not 360 degrees, it is 2 pi radians. So that would be the first goal when we are dealing with these in Math 30-1, is to recognize how to measure all angles from standard position. So going clockwise from the positive x-axis, measured in both degrees and in radians. So that is the first content that we're going to look forward to.